Welcome back to Module 3. In this session, we'll look at the practical side of SIP construction, panel sizes, how they're manufactured, and how shop drawings guide the process. If Modules 1 and 2 gave you the why of SIPs, this one focuses on the how. Structural insulated panels, or SIPs, are made in different thicknesses. The most common sizes are about 4.5 inches, 6.5 inches, 8.25 inches, 10.25 inches, and 12.25 inches thick. The thinner panels, like the 4.5 and 6.5 inch SIPs, are usually used for walls. The thicker ones are more common in floors and roofs, where extra strength and insulation are needed. In terms of dimensions, SIPs can be manufactured anywhere from 4 by 8 feet all the way up to 8 by 24 feet. That range of sizes gives architects and engineers a lot of flexibility. You can design walls, floors, and roofs that span anywhere from 4 feet up to 24 feet wide without needing intermediate supports, which you often see in conventional stick framing. So, in short, SIPs offer both variety in thickness and versatility in size, making them useful for almost any building design, typically. SIP wall nominal thicknesses are 4.5 inch and 6.5 inch. The EPS core thickness for these nominal wall thicknesses typically correspond to dimensional lumber sizes of 3.5 inch and 5.5 inch. The typical OSB facer used with SIPs is 7/16 inch in thickness. This equates to a SIP wall thickness that is marginally thicker than the conventionally framed wall. Even though panels are produced in standard sizes, every building is different. That's why SIPs are cut to order in the factory. Openings for windows, doors, electrical chases, and even roof pitches are pre-cut before panels leave the plant. This factory precision improves quality control. Instead of cutting with a saw on site, and potentially introducing errors, the panels arrive engineered and labeled, ready to be assembled like a kit of parts. Shop drawings are the roadmap for a SIP project. They're prepared after the architectural and structural drawings are complete, and they show exactly how each panel is laid out, numbered, and connected. Think of shop drawings as a bridge between design and construction. They account for structural loads, HVAC and electrical chases, plumbing routes, and more. Every SIP panel is identified with a code that installers can match to a panel on site. Without accurate shop drawings, installation could slow down or lead to mistakes. With them, SIP construction becomes fast, efficient, and highly predictable. To make the process seamless, manufacturers mark every SIP with labels that correspond to the shop drawings. This way, a panel labeled W12 can be immediately identified as wall panel 12 feet in the construction sequence. This level of organization is one of the biggest advantages of SIPs over conventional framing. Instead of figuring out how to cut and fit materials on site, the installer simply follows a coordinated map. Because SIPs are manufactured products, tolerances are much tighter than with conventional stick framing. Panels are fabricated with CNC routers or precision cutting systems, so openings for doors and windows align with exact measurements from the shop drawings. This precision is especially valuable when integrating mechanical systems, like HVAC ducts or electrical chases, which we'll explore in later modules. It also makes SIP buildings more airtight, because panels fit together with minimal gaps. Let's start with blank SIPs. These are the most basic and least expensive option up front, but they require the most work on the job site. All of the cutting, beveling, and recessing has to be done on site. That means more labor, more waste, and a higher skill level to get it right. They're usually produced in stock sizes, from 4 by 8 feet up to 8 by 24 feet. Blank panels are often chosen when drawings aren't finalized yet, or when the contractor needs panels quickly and can't wait for factory prep. Next are prefabricated SIPs. These are prepared and cut in the factory according to the shop drawings. This improves the fit and finish and makes installation much faster and cleaner. Electrical chases and foam recesses can be added at the factory, but lumber isn't pre-installed. That actually helps electricians with access for wiring. Prefabricated packages often come with everything you need, like lumber, splines, fasteners, sealants, and weatherization materials. The big advantage here is reduced waste and quicker dry-in of the building envelope. Finally, we have ready to assemble, or RTA SIPs. This is the most complete option. RTA panels arrive with internal lumber, headers, door and window openings, wiring chases, and beam pockets already built in at the factory. That means when they show up on site, they're almost ready to install immediately. Only sealing, taping, and final fastening are needed. Not every manufacturer offers RTA packages, but when they do, they save the most time and labor. So, the bottom line is, the more work done in the factory, the faster and easier the job will be on site. Blank SIPs demand the most from installers, while RTA packages deliver the highest efficiency and precision right out of the truck. To summarize, SIPs come in standard sizes, but they're custom manufactured to fit each project's design. Shop drawings guide the process, panel labeling keeps the build organized, and factory precision ensures tight tolerances and airtight construction. In the next module, we'll build on this knowledge and discuss how SIPs are installed on site, including sequencing, handling, and best practices during construction.